Okay, welcome. Thanks for coming. Thanks for the organizers. Thanks to the organizer for inviting me around Thursday evening or so.
We didn't want to give you enough time to prepare your arguments. No.
Well, that
thanks
was
for stepping
that
in.
was a
That's,
marvelous success because I've done these slides last night.
Well, thank you for coming and stepping in.
We'll see. Okay, so this is all prepared in the last moment on the basis of stuff I had, but I really changed it, and I stopped changing it last night, 20 after 2. Good. So the title of my talk. Okay, this is radically enactive computation. I'll tell you about the rec point of view of computation. One more note about it. This stuff is a bit is unfinished. I'm working on a new book with them. This is the part of the book that still is under discussion, and I've left out some parts which my co-author and I are still heavily discussing about. Good. So I shall first say something about radical enactivism, radical enactive cognition, or REC. Tobias.
Yeah, you got it.
This is a cool T-shirt. I'll say some things about REC in a nutshell. REC is all, or a major focus on REC is on non-representational cognition. REC claims that at least what we call basic minds are minds without content. That was a subtitle of our book. Now, in order to make such a claim, you'd better have a definition of content. You'd better specify what content is, or otherwise it's not clear which position you are defending. So we made clear that what we mean by content is... Oops. I'm going. Good? Yeah. I won't touch you again. What we mean by content, and it's a definition we've taken from how other people often write about content. We use content such that it involves truth or accuracy conditions. If you don't have that, you don't have content. If you're not committing to truth conditions, accuracy conditions, something equivalent, you don't have content. That's one part of our notion of content. Another part of our another way which we characterize content, and it's also very traditional, is by saying that content has both an aspect of intentionality with a T, there's directness to the world, but, and that's specific for content, when content involved, you also have intentionality with an S. You have representing as, representing under a description, or whatever way you want to fill that out. Good. Now, where does this go? Okay, I see. It's new also. So let's then, given that definition of content, we can characterize REC on a continuum or on a line with different positions in the following way. REC doesn't deny content in total. REC is not a form of content nihilism. We don't say that there is no such thing as representation in the world. We're not, or content in the world. We're not absolute representation or content deniers. Some people are. Jasper, here in the room, at least, defended such a position in his master's thesis. Matthew Harvey has written a paper which is content nihilistic recently, and these people who endorse content nihilism tend to accuse records of not being radical enough. Good. Now, we don't endorse that. We think there's content, but content has to be situated at the socio-cultural level, especially in language. There you have truth conditions, accuracy conditions. I'll talk about that immediately. So you have, according to Rec, content in language. That language, therefore, is intentional, it is contentful, and it is intentional with an S. Language, obviously, gives you, presents you things under a certain description. I say is okay, good. So this is all fine. But what about content in what we call basic minds? Minds which, which you can think of as minds perfectly, but approximately minds which haven't been in contact with language. Well, in basic minds, we claim you have no content. That doesn't mean that basic minds are not intentional. So we don't equate intentionality and content. You can have content-free intentionality, but such intentionality is not intentional. Okay, and the idea is that organisms can be directed towards aspects of the world without representing these aspects of the world under a description. Okay, you react to perhaps very specific things in the world, but your reaction itself is not contentful, it is not intentional. You don't see those things under a description as having a content. Okay, do we have there,
Okay, one through.
So I conclude. Do you have content? Another possibility would be content in non-biological nature. Pan-computationalists might think that that's a good idea. For example, of course, Reckers deny that too. Good. Oh, wrong way again. Here I go. Okay, what's the motivation? Why do we say these things, or why do we hold that position? Well, first there's a critical motivation, and that critical motivation starts from the fact that the best naturalistic accounts of content which we currently have, and we think the best of those theories are teleosemantic theories which involve a combination of function covariance, but not only covariance. Our book was based very much on covariance, but we also want to include theories that talk about isomorphic structures isomorphic structures that might involve things like internal error detection. Well, if all these aspects are coupled to function, according to many teleosemantic or similar theories, you get some kind of content in an organism. Well, we say those best naturalistic accounts of content, they only give you intentionality. They only give you directedness towards certain aspects of the world, but they don't give you truth and accuracy over and above malfunction. We think malfunction falls short of providing you with accuracy conditions or truth conditions. Moreover, these functions don't in themselves give you intentionality with an S. Okay, so according to according to such a theory, such teleosemantic theory, which involves functional isomorphism, perhaps with error detection, you can get directedness of an organism and perhaps some of its internal mechanisms on the world, but that does not yet give you content. It might tell you a story. That's something I hinted at in the reaction to Francis Egan. It might give you an account of how, due to its internal organization, a creature coordinates with the world. Might give you perhaps a detailed story now, but that is still not a story about content. It's perhaps a story about intentionality, but not one that gives, and it's a story which gives you malfunction, but it doesn't give you truth, accuracy, or intentionality with an S. Okay? That's basically the rec position. Or the negative motivation for the rec position. We also have a constructive motivation or a constructive program, and that pertains to the kind of content which we recognize, and that is content in language. That kind of content is intentional with an S. The idea of truth conditions applies to it sometimes to some parts of language. Now we think that you can naturalistically account for such thing, for such content, and you can do so via a natural history. What's a natural history? A natural history is an account of how the capacity to acquire language which is contentful has arisen through a history which involves cooperation, which involves co-cognition, which involves communication, which involves mutual correction, etc. Such a natural history is non-reductive. We think it's not giving a kind of a definition of content in terms of only causation and function. For example, no, you have to have a complicated natural history story. It still gives a role for biology, but the content doesn't flow out of the biology directly. You also need to take care or have attention in that story, crucial attention for the social. That, we claim, gives you content and intentionality. At the end of such a story, you see that in language there are truth conditions, there is objective truth, there is intentionality representing us, etc., etc. Okay, and I'll take for granted now that such a story can't be provided. We haven't provided in any detail. Dan has a paper which goes a bit deeper in it. In our next book we will say something more of it. But let me assume as a background assumption that such a thing can be given. No. Sorry. Good. Okay, and now in this talk I want to see how from this perspective, from this rakish perspective, one looks at computation. I have two goals. First, I want to further illustrate the radical enactive position, but I also want to deal with computation simply because it's a crucial issue on its own standing. Good. So, here's the structure of what will follow. I'll talk about reckoning and computation. I'll first talk about reckoning, what I call reckoning. Whoops. Sorry. Reckoning. Then I'll talk about computation in physical systems or physical computation. And I've left out that last part, I must say. Good. Okay. Reckoning. What's reckoning? Reckoning is how computation, contentful computation, should be construed and is construed within a radically enactive view. Okay, when contentful, or when Rec wants to talk about computation, it fundamentally thinks about computation as a social cultural practice. And you could think of such examples as a child calculating a sum on a blackboard, or here this is meant to be a scientist doing a complicated calculation somewhere in her office. Now, this is the fundamental kind of computation according to Rec. Call it reckoning for that reason. And it has some features. It involves overt activities, it often involves the manipulation of public symbols, and this happens according to intersubjective and socially established norms. Now, how should we account for this reckoning, for the kind of computation that recognizes as computation? How should we account for it? Well, according to what I said earlier, we should account for it in terms or via a natural history. What does a natural history do? Like in this case, the natural history of bikes. It tells you how a more complex structure gradually emerged from more simple structures. Can we provide a natural history of reckoning? Well, we can at least hint at one. We can find sketches. One can find the beginnings of it in books like this, Numbers, Their History and Meaning, by Graham Fleck. He gives a natural history of what I call reckoning. I'm thereby mean computation in general, but the natural history of reckoning, I think, is the natural history of reckoning in the usual sense. Okay, reckoning this way is computation, a la reckoning here is just calculating, doing elementary arithmetic. Now, how does that arise? Well, inspired by that book. Oh, you can't read that. In that book, you see nicely how you can give a story about how such capacities as adding arise gradually from simpler capacities. And here is, I can't even read it here. Here's supposed to be written a basic sense of size and shape. That's a very basic capacity. If you have that capacity, that's a prerequisite for putting things in a one-to-one correspondence with parts of your body. And if you have that capacity, you could have the beginnings of counting. And if you have the beginnings of counting, you can go on to acquire such capacities as adding. Now, as that book makes clear, that the book I mentioned is very clear in insisting insisting on the gradual nature of such progression. It says, rightly I think, counting is an advanced process. It is by no means as instinctive and innate a process as it might appear to be. So that means that it has simpler beginnings. People didn't just start to count. They started by, as I said, by marking those one-to-one correspondence with things in the world and parts of the body. Now, just as an aside, that's a thoroughly embodied process, and you can see traces of that in well, forgive me the politically incorrect expression, in primitive languages, in which you, for example, have these words or these descriptions for numbers. The one is bent, another one, the middle one is bent, another one. Okay, you can clearly see how such early number words arise out of the one correspondences that are established between parts of the body and things in the outside world. Good. Now, counting starts from simple capacities, but early forms of counting still do not amount to real arithmetic, a real capacity to deal with numbers. As our author stresses here, the process of counting involves direct correspondence between object and figures. There is no requirement for an awareness of numbers in the abstract. Okay, so the idea is that initially people could count but didn't have a number sense. So there is no such thing as a natural number sense, which lies at the basis of our counting capacities. our author stresses that also by writing this, going from the association of 3 fingers with 3 sacks of corn and with 3 loaves of bread to an appreciation of treeness and hence tree in the abstract involving intellectual leap of considerable proportions. So you have primitive forms of counting in which 3 sacks of bread are not seen as being related in a way in which we see the relation with 3 loaves of bread with 3 sacks of corn. Okay, and you can see that in language because there are different words for 3 things of that and 3 things of that, and only after a later stage one word arises. Okay, whatever the details of this natural history, it seems to me that it's quite clear that there are no fundamental obstacles to give a natural history of reckoning, so of calculating, and therefore, because the natural history of computation, a la reckoning, written that way, is the natural history of reckoning, therefore no fundamental obstacles to give a natural history of that. But the important thing is that reckoning, computation, is an achievement. It's not basic. That's very fundamental to the rec view. So it's a building which is built on all these foundational capacities. It is not something that was there from the beginning and on which you can build the rest of your cognition. Some features of reckoning computation are the following. It is contentful. It is true or false. If once these practices of calculating are established, it's a mistake. It is false to write 5 plus 1 is 7. Okay. Okay. So there's contentfulness, truth conditions. Reckoning further is determinate when the practices are established, and a child is, for example, a child in a certain culture is making a sum on the board, and what is written in our culture and what is written there is 5 plus 2 is 7. We don't have to engage in questions about what calculation is thereby performed. We know that is determined by the practice in which the child is participating. And the last feature, which I don't know, which is important, but I don't know if it will be very important this time, but it is important, I think. Reckoning is internally determined. That means it is the content is constituted or established by the socio-cultural practice. It's not, so to say, imported from elsewhere. It's not gotten from neither a Platonic realm or from some other practices or from I don't know what. There can be external pressures on arithmetic and reckoning capacities. So, for example, an idea that is often encountered is that people start to use negative numbers when certain societal needs arise to lend money and to keep track of those things. So in that way, the practices of reckoning, they change, but the change doesn't come from without. There's some pressure from within, but that pressure from within, from without, has as its effect that the practice changes from within and adapts to the needs of the changed environment. Good. That's all good. That's Rek's view on computation. So I could stop here, but I won't. Because I want to say something. I need to say how Rek views what is often called computation in physical systems. I think that's Gualtieri's term, or did you get it from someone? For physical computation. Good. It's a term which is in use, and the term is widely used in the cognitive sciences and elsewhere. with the idea in mind that behind those practices which I talked about in the earlier part of my talk, that these are sort of deriving from or related to other kinds of computation which are in many ways fundamental, well, mostly which are taken to be explanatory computational events which are explanatory with respect to what happens here. Okay, so practices are only possible because there are other computational processes occurring at a physical level and which explain those practices. Okay, it's computation in physical system. The term is also meant to apply both to what happens in brains, and it's also assumed that computation goes on in artifacts such as computers. And here's an expression by Larry Shapiro of this hierarchy, this order, this relation between those Here's an expression of the fact that this kind of physical computation is taken to be basic in an explanatory way. Cognitive science has a subject matter capacity for perception, attention, language processing, and reasoning. The concept of cognitive science takes to be essential for understanding their dominant information, representations, and our algorithms. And he remains neutral whether these things are to be implemented in more traditional computational architectures or computational networks. Okay, so computation here forms the basis of the practices, and of course there is a name for that idea. It's computationalism, and here is an expression of computationalism by Chalmers. Computation provides a general framework for the mechanistic explanation of cognitive process and behavior. That is, insofar as cognitive processes and behavior are explainable mechanistically, they are explainable computationally. Okay, now at the same time as being so confident about the role of computation in explaining cognitive practices, at the same time one finds the same people who express that confidence also expressing worries about this supposedly foundational notion. Here's David Chalmers in his paper on computation. He says, computation is controversial. Questions about computation abound. And a very central question about computation is a question about individuation. When is a certain physical process a process of physical computation? Okay? Here you have these stones arranged in a way, well, you could easily have the intuition that there's some kind of computation going on. But look at this, you have these stones here, they're all on top of each other. Are they computing the weights of their of all these stones together? Are they adding? Are they? We don't know. We don't know. Oh, well, it's difficult to answer that. And if you don't answer that question, the danger of if you don't have we need to answer that question in order to answer the question whether pan-computationalism is true, whether everything that exists computes. Good. Now, in the thought about computation, we have seen, in the thinking of computationalists about computation, we have seen a movement from semantics to the non-semantic. Okay, early versions of computationalism, version 1.0, started from the assumption or the axiom, say, expressed here by Jerry Fodor, that you have no computation without representation. Now, Marx Privak called this the received view. This is not Marx Privak, this is an icon of receivedness, tradition. the computational processes involve computational states which have their content essentially. That's how it has been expressed. Not Seeger, but another expression of that, of this semantic thrust in computation is the whole thrust of cognitive science is that there are subpersonal contents and subpersonal operations that are truly cognitive in the sense that these operations can be properly explained only in terms of these contents. Okay, that's the traditional established view. How one can be very traditional and established, but still face dangers, face problems. That's certainly the case for this kind of computation. Well, because, according to at least Rec, the semantic accounts of computation have to solve the hard problem of content in order to be workable. Because without, they need to say where in computational systems content arises. Well, they have to say, they have to have an account of content in order to say which systems compute, as computation involves content, and which systems don't compute. And if they don't have an account of that in hand, they don't solve the individuation problem, and they don't tell you which systems in nature compute and which don't compute. Good. That's old school computationalism. There's also new school computationalism, and that is the non-semantic kind. Here are two motivations for non-semantic computation. The first one is from the, now it's a different paper, I think it's the same paper by Chalmers, and Chalmers refers, I think, to some version of the hard problem of content. He says computation is foundational, but the notion of semantic content is so ill understood that it desperately needs a foundation itself. So it's the kind of problems with content which Rec wants to point its finger to, which also motivates Chalmers to go non-semantic in his account of computation. And here's Gualtero, who has another motivation. Chalmers gives this one also, but here it's very well expressed. Another motivation to go non-semantic is that you don't want your theory of computation to become circular. You don't want to define computation in terms of content, and then content again in terms of computation, which would make your whole account circular, of course. Okay, now according to this semantic view, physical computational processes do not have their semantic content essentially. But that doesn't mean that they might still be content bearing. It's just the fact that they don't have that content essentially. So people who propose a non-semantic view of computation don't have to be records, don't have to deny, or don't have to be content deniers, even for the computational processes they are talking about. Good. How can one elaborate, expand, or elaborate on that non-semantic computation? Well, the proposal very roughly, and this is only roughly, the proposal is that physical computation occurs when you have a specific pattern of causal organization. Computation has to do with, well, sort of combinatorial systems in which patterns regularly occur, to say it intuitively. And a second component, which these authors insist on, is medium independence. Computation is medium independent. You can have the same computation in a variety of meanings. Multiple realizability, which we know from functionalism. Okay, now you can then further elaborate that in different ways. Here is something that Chalmers says. Chalmers says you have physical computation when there is an isomorphism or mirroring between the causal structure of the physical system and the formal structure of the computation. And that's quite worrisome to use that as a characterization of physical computation, especially when one wants to solve the individuation problem, of course, because, well, it seems like you have already decided which are computations and which not, because you have a formal model of the computation, and then you go and see whether there's an isomorphism between that and the causal structure. Okay, question is here, well, where has it been decided that this formal structure is a structure of a computation? So that's quite problematic. And here's another proposal which doesn't have that problem, the Chalmers problem, and that's Montero's proposal, which I'll only sketch in rough outlines. He says computation concerns the processing of vehicles according to rules that are sensitive to certain vehicle properties and specifically to differences between different portions of the vehicles. Okay, so the idea is, well, it's clear enough, I think. Processing, so it is said, is performed by a functional mechanism, that is, a mechanism whose components are functionally organized to perform the computation. Now, in both accounts, as I said, multiple realizability plays an important role. The idea is that you have some kind of abstract causal structure, an abstract structure, patterns which could be repeated in different media, and that you have different sensitive rules which are sensitive to differences between parts of patterns, however these patterns are further physically instantiated. And the rules are seen as input-output maps. Okay, suppose this non-semantic account of cognition is correct. How can one frame that within the goals of computationalism? That's actually asking for how this computationalism relates to cognition. Now, the relation to cognition of computational processes wasn't problematic, I think, in the original form of computationalism, in the semantic form, as you can see from the quotes I gave from Seeger, because it seemed obvious to those early computationalists that you would get an explanatory relation easily between those subcognitive contentful processes and the contentful processes which were the more visible cognition. But what if you throw away the semantics? How can you still retain this link between computation and cognition? Is the link there because cognition concerns abstract patterns of causal organization? Well, that's problematic because every physical process has some abstract pattern of organization, and if it's the abstract pattern of causal organization that defines computation, then pan-computationalism looms again. Now here's a way in which you can try to accommodate these concerns. And again, I go to Chalmers. Chalmers has this idea of essential multi-realizability. Chalmers expresses in his paper the idea that unlike other physical processes, computational processes are not just, they don't have this abstract, multiply realizable structure. No, they also are what they are because of this abstract multi-realizable structure. Okay? For example, if you have digestion, and you give such an argument also, I think, if you have digestion, you could study that process and see some kind of pattern inside that process. And you could then replicate that pattern, but by replicating that pattern in another medium, you would recreate that abstract pattern and perhaps that computation, but, or you would, let's say, you would recreate that abstract pattern, but once you have recreated an abstract pattern, you wouldn't have recreated digestion. And that is because digestion isn't what it is because of its abstract pattern. But if you take something like calculation, or like the abstract patterns that you find in a calculator or in a computer, if you duplicate these in another medium, you would have duplicated not just the abstract pattern, you would have duplicated the computation, you would have duplicated calculation. Good. Okay. Is it a good idea to define computation or that's relevant for cognition by means of essential multiple realizability? Well, I think the answer to that question is, in the first place, well, that might run into empirical problems. We don't know currently whether human cognition is actually multiply realizable. Take, for example, an example which I've taken from Anderson's book. Connection is, or well, on some assumptions about what neurons do, on some simple assumptions about what neurons do, one could have an idea of what is essential to neural functioning, but that idea might change. Okay, we might have thought that the firing of the axon was the essential activity of the neuron, and because that is realizable, multiply realizable, we might think on that conception of the neural base that cognition is multiply realizable. But the fact is that we, at this moment, don't know which factors which happen in our brain, which processes which happen in our brain, play a real role in cognition and which don't. And you see, and that's why I go to Anderson, you see that those conceptions are changing. Anderson talks about glial cells, which were thought to be purely structural, and now it turns out that these play a part in, or are an essential part for the cognitive functioning of the brain. And you could expect that other properties than the ones Anderson talks about would become relevant too. Good. Another question about multiple realizability concerns embodied cognition. On many readings of embodied cognition, some cognitive acts are dependent on the specifics of the embodied creature that performs these acts. Okay? For example, if you think that a mouse that escapes through a narrow hole performs a cognitive act, well, perhaps that kind of cognitive activity is has its specifics because of the specific embodiment of that mouse. So we don't know if cognition is multiply realizable. So there are some empirical problems with respect to multiple realizability, but there's also a conceptual problem. If you want to take or to place too much importance on multiple realizability as an aspect of computation which makes it relevant for cognition, why does it matter for cognition that mechanisms behind cognition are multiply realizable? It remains possible that some non-cognitive processes are multiple realizable too. Okay? So if you use multiple realizability as a criterion for the individuation of computational processes, especially important for cognition, you face that problem. Okay, here's Gualtiero's comment on Chalmers, which might be motivated by such problems. He says that Chalmers collapses the notion of computation into causation. So he sees a problem with Chalmers' account because it's too causal, and he gives a new proposal, or he proposes to add a component which we know from which one might expect perhaps, and that's function. Okay, but now it seems, okay, the idea is now that you have computational processes in physical systems when you have multiple realizability plus sequence of functions. Okay, now the question becomes again, why is this the kind of computation that is characterized by these two things, why is that especially relevant for cognition? It might still be possible that some non-cognitive processes are both multiply realizable and functional. So they would be computational but not cognitive. Another option to delineate the computational from the non-semantic point of view, which Gualtiero takes, is by going technical. For example, you could say, well, all those abstract combinatorial systems which fall under my description of, or my stipulation of computation, I delineate, or there are some which reduce to the kinds of formalism which Bitz and McCullough talked about in their papers of neural nets. And then you have a clear demarcation of what's computational and what's non-computational. And then you say, I think, and then it becomes a further an empirical question whether the brain is a computational device or whether it is not. And it becomes an empirical question whether cognition is computational or is not computational. Now that's certainly true that once you go technical in that way, that it becomes an empirical question whether processes in the brain are computational or not computational. But the question is why such going technical, or how it can be motivated from a cognitive perspective. Okay, the fact that it could turn out to be that brain processes are not computational in that sense shows that the going technical is not motivated by a cognitive point of view or from a cognitive perspective. Okay, one could also say this might be a bit of a bad analogy. One could also say, well, only those processes which involve dopamine are computational, but that wouldn't, and that would draw a line between certain processes in the brain and other processes. But from a cognitive perspective, such a delineation would make no sense. Okay, and I have 1 minute. Can I take 2 or 3? Okay. Good. Okay. An additional problem for non-semantic computationalism is that content will have to be brought back in at some point. And we don't know how that can be done. I'm almost finished. Okay, let's then return to rec. Okay, I see on the rec view, as far as we currently know, computation only exists when people participate in social cultural practices. Okay, all the other forms of computation are not established or have not been established for the right reasons. There are currently no reasons to assume that follows from that either computers or brains compute. There are no reasons for semantic computationalism because the hard problem hasn't been solved. There are no reasons currently for non-semantic computationalism. Yeah, and I do this very quickly. Well, another reason for that is the insistence of non-semantic computationalists that physical computation is not essentially semantic. So the idea from the rec side is that if that is true, the kind of computation that goes on in brains, or what is labeled as computation, can't be the same natural kind as what goes on in a social cultural context. So there is no natural kind of computation, so whatever happens or gets labeled as physical computation, it is not computation. Computers, then, according to Rick, this I should have. Computers, well, they don't compute. Though we might be said to compute with computers. That's correct, but computers themselves don't compute. Or it hasn't been established that they compute. Computers, from this perspective, are, well, like what Hawkland said about self-moving symbols. They're like systems of self-moving symbols. They're like pages on which the symbols themselves move in certain ways, but they thereby compute. Though, just like we can compute by writing things on paper, we can compute with computers. And for all we know, brains don't compute either, though they are part of the physical underpinnings of cognition, but as far as we currently know, in a non-representational and non-computational way. That's it.
Yeah, just one clarification, a couple of clarifications that might help you out. One, Chalmers explicitly endorses pan-computationalism.
Yeah.
So if you don't like pan-computationalism, that's an excellent way to criticize Chalmers. And medium independence is a stronger condition than multiple realizability. So you can have multiple realizability without medium independence, but if you have medium independence, you do have multiple realizability, but medium independence is stronger. So if you're already skeptical about multiple realizability, you're going to be even more skeptical, most likely, about medium independence. So that's more ammunition for you.
Thank you.
Okay. Done. Albert?
Yeah, thank you. Thank you very much. May I bring one example from animal cognition, which I did not bring in my talk, because this example seems to be in need of content, but it's clearly non-linguistic. And the example is coming from rats, which are trained in an 8-arm maze, and the rats are able to learn a behavior which can be described by the following conditional. There's 8 arms, and they search for food in the morning. They can represent noon time based on light, and they are behaving according to the conditional. If you find chocolate in arm 2 in the morning, you will find chocolate in arm number 7 at noon. Mm-hmm. So that's just a description of the behavior that rats can rather easily be trained. The work of John Bristol in Bloomington, and it seems to be that there is some need of representation with contents because there are distal representation of places and times, but there is no language involved. Mm-hmm. And it seems to be our approach is we can go without content except for language.
Good. Well, that's a very. I have a lot to answer to that question. Actually, I think I'm not sure, but it might be that Dan Hutter treats with that example in his folk psychological narratives book. He has, or
No.
something. No,
That's
something.
a more recent
Okay.
study.
Good. Well, one superficial thing you say, it seems to me that it can't be explained in another way than by a representation. Good for you that it seems to you that way, but that's no proof that it can't be explained in another way. You feel that urge, or well, you talk about your intuitions, you don't talk about what's the case. We'll see at the end of science whether it needs to be explained in this or that way. And then a second thing, you don't have to underestimate the resources that are available to REC, because if you would like to involve simulations of previously encountered paths or so, there is space, or it's possible for REC to, for example, invoke those, but insist on the fact that these are not contentful. Okay? So, for example, I'll give you, I'll treat you as if you gave a different question. But it's similar. It's similar, and it's a similar. Well, there's this often encountered argument that REC can't account for kinds of cognition which invoke the absent, like in imagery or so. But REC can perfectly account in both that, and I have written about that. REC can perfectly account for a primitive form of imagination which doesn't involve memory, which doesn't involve language, but which involves reenacting some experiences which were previously had, and acting on the basis of that reenactment. And so we could have those things which seemed in principle impossible for REC to account for in a non-contentful way by such means. But I don't, yeah.
The basic challenge is, we leave it at that, the basic challenge is that there are kind of basic non-linguistic minds which show non-basic behavior, and then you're kind of in trouble because you're clustering.
No, because well, our definition of basic behavior is not stimulus-response behavior. It is sensitive to contextual factors, to the history of interactions. We just say that these factors can influence current behavior without being mediated by a contentful representation. That's the view.
Okay, next question, Mike.
Just to request clarification, there seem to be two directions of argument floating around about multiple realizability. And one we can just put aside, which is the claim, I mean, not because it's wrong or right, just because I don't want to focus on it. That's the one where you claim that cognition, there's some evidence from embodied cognition, for instance, that some people at least don't think of cognition as multiply realisable at all. So let's put that one to one side and think of a different thing. There seems to be an argument that went along the lines that when you give a theory of computation multiple, and you might go down the line where you take multiple realisability to be something that helps fix the notion of computation. So we're in the non-semantic camp, which wouldn't be the way I would naturally go. Let's play in that camp. So you have you make some move where you say something like multiple realisability or something stronger, like medium independence, is kind of special to fixing the notion of computation. I couldn't see how the argument was supposed to go then against the idea that you could use that notion to help explain cognition. Of course, no one ever thought that the only things that computed were cognitive systems, right? When we were trying to give a computational theory of cognition. The idea was there's this phenomenon, computation, that some special subset of, when we get the right functions and the right rules and so on, would explain cognition. So it seems to me some of the worries there are a bit misplaced. I mean, it could be that all kinds of things compute, right? All kinds of things all over the world. Maybe you don't want a pure pan-computationalism, right? Maybe Chalmers got wrong there. But it could be that loads of things compute, CD players, all kinds of things. That wouldn't show the notion of computation wasn't relevant to understanding cognition. it would show that we need to fix on a particular subclass of computations, which I take it is the kind of move where you start appealing to things like McCulloch to sort of narrow down the class. So I wonder if there's a bit of argument that's not quite in place there yet, which...
Okay, yeah. But I relate to that. Yeah, but if you narrow down that class, you would have to have a motivation that narrowing down is relevant for cognition.
That's right.
And that is absent, I think.
Okay, so that's sort of okay. All right. So, but then, surely the history of cognitive science shows that what people tried to do with the notion of computation was not just say, I'm a computationist and any old computation does cognition. What people tried to do is say there's some subset of computations that explain cognition. And if you like, so the whole of cognitive psychology is the attempt to work out what those computations are. So I don't see it as a kind of direct worry. The fact that lots of things compute doesn't necessarily mean that it makes that notion irrelevant to the understanding of cognition. You're right, there needs to be more of a story about what those particular subsets are, but that in itself wouldn't block the notion of computation from being relevant.
Okay, no. But I use that argument also because it's what Chalmers gives that as the essential, that what distinguishes cognitive computation from other computation.
Right. So I think Dave, if Dave makes, I don't know that, but if Dave makes that argument, I think Dave's wrong about that. The way I heard it, was the notion of multiple realizability or medium independence was helping to fix the notion of computation, and then of course we'd need much more work to show which subset of those computations would be relevant for cognition. But if Dave's trying to use that notion to fix the notion of cognitive computation, then I think that is a mistake. You're right to point that out. But I don't think that's anything that anyone in cognitive science says.
Okay.
No.
Andy?
Yeah, so I wonder whether in a way it's maybe not the notion of computation, but the notion of physical systems that we think of as computers that should be doing more of the work here. So if you ask what might systems like that, as physical systems, have in common with brains, the answer might be something like, they're locuses of cheaply reorganizable plasticity, something like that. And I think an awful lot of the intuitions that people have here don't depend very much on the details of computation. They just depend on this idea of a system that is cheaply reorganizable. Cheap reorganization does seem to be something that brains have quite a lot of.
And is that computational, according to you?
Actually, at some level, yeah, I think this would fit quite well with Chalmers' view. But yeah, at some level, if you can cheaply reorganize your states, then you can implement all kinds of processes that we think of as computational. But it's the cheap reorganization that's doing the work. It's not a kind of ontological claim, if you like, that it's a computational system in some other sense. It's just cheaply reorganizable. So I wonder whether that's... is that one contributor?
I don't know. It's not a very precise notion, yeah? Well, listen, I said, there's no denying that brains are part of the physical and underpinnings of cognition. Nobody wants to deny that. And it might be due to cheap reorganizability, but I don't know. Well, but I'm not that.
A lot of energy to maintain yourself in a cheaply reorganizable state.
Mm-hmm.
See what I mean? So
Yeah. Okay. But I'm not so confident that that relates to computationalism the way you seem to assume.
So I have a few things, but I think the first thing is that you left out an important part of Gualtiero's view about computation, which is that even though computation might be medium independent, it's not structure independent. Is that right? Because not all vehicles will be implementable in all mediums, right? Is that correct, Gualtiero, or am I getting something wrong here?
I'm trying to follow. I'm not totally sure. So, can you give an example?
That there's just some structural relations that are specified by the vehicles of the computation that will not be implementable in all mediums. Right?
Sure. So you need certain degrees of freedom.
Yeah, exactly.
And to be able to implement a certain kind of computation.
Yeah, and it seems that this notion of degree of freedom is relevant for why we would want to, for why McCulloch and Pitts wanted to ascribe like a certain computational function to the neurons, right? So this was the reason why they thought that neurons do something that is like something else.
Sorry, say it again?
So the idea is that there's not every computational function, because of the vehicle specified, will be mappable to every medium, right? Implementable in every medium, in this sense, something like that. So if that's the case, then the reason why we would think that the brain is doing computation is because there are certain structures in the brain that suggest that certain vehicles might be implemented in the brain, and that's exactly the kind of inference that McCulloch did.
But you already know which the vehicles are.
Well, you know
on what basis do you decide that?
You know that they have to have some properties for certain computations, right? And then you look for some kind of possibility of implementing those properties in are these vehicles in a physical
How do you
medium.
know? Well, but how do you get your start properties?
Well, I guess that's a kind of a abstract problem, right? That you have to figure out by figuring the structure of the system. No, it's supposed
Yeah,
to be
but
the computation.
and how do you motivate that you pick out those properties?
So the standard story is that people were trying to figure out what the neural signal is in the 20s, and they finally managed to identify the action potential as the thing that drives the muscle fibers. And so then they also figured that it's action potentials that are sent out of sensors in the body, and these action potentials seem to be, roughly speaking, invariant over whatever medium is transduced into them or they're transduced into. So especially with respect to sensory systems, it's clear that there's action potentials coming out of the retina, the cochlea, all this different kinds of sensors in the skin and the muscles, and then they all kind of go towards the nervous system and they get processed. And of course, different neurons fire in different ways, but they all send these action potentials, and especially for sensory systems, the rate of firing seems to be very important to hearing information about what's out there. So, so that's where this idea of medium independence originates with Edgar Adrian and thinking about nervous systems as transmitting information. Then McCulloch and Pitts had a specific view about how the processing gets done. That's wrong. Their theory is clearly wrong and abandoned by mainstream neuroscience, but it's replaced by modern computational neuroscience accounts.
But just to return to this structure problem. So for example, yesterday Andy said another example would be like, if something is supposed to be doing hierarchically structured Bayesian inference, right? Then it has to have a certain structure between its elements. Otherwise we won't say that it's doing that, right? So in this sense, you would look for those structures.
Yeah, sure.
And if you found a structure that was similar to something else, you would say, oh, it's possible that this thing is implementing that thing, right?
Right.
And this is, it seems that this is the kind of inference made by people like Carl Friston when he's building those models.
Sure.
But that's one issue. The other thing is that you said that computers don't compute.
Yep.
And it seems that it's a long-standing tradition that for something to be a definition of computation, you want the right things to compute and you don't want the wrong things to compute, right? And on your account, if I got it correctly, a universal Turing machine computes only in as much as, or it's said to be a computational system only because of some kind of linguistic.
No, it's said to be. It's said to be. Well, take a calculator for a simple example. A calculator is.
No, but I want to take the Turing machine.
But let's start with the calculator, and then tell me what the Turing machine adds. Why does a calculator compute? Well, because there's this. I don't know which word you used. Because there's this. According to me, why people say that is because of this structural isomorphism between the operations, you've said this morning, between the operations we do in calculating and the things in the machine. So there's correspondences between the numbers and states in the machine, and there's correspondences between the operations. And once these correspondences are established, you have computation. It is said. But I deny that this correspondence suffices for having computation. Because if I were to accept that, I would have to accept. It would be hard for me not to accept it as some kind of teleosemantic or structure plus function theory about content.
Okay. So now, if we
now
take it to the Turing level, or
Okay,
we can take it to...
No, you have to take it to Turing level, so
Okay.
you can only take it to Turing level.
No, but we can stop now and I can just...
Take it to a Turing level.
We have two questions. If you're very, very short, you can discuss.
Okay, fine. According to REC, computation only exists when people participate in social cultural practices, and reckoning is internally determined. Now, these two theses indicate that the burden of an account is going to fall on social cultural practices. And the social cultural practices are then supposed to give us the normative or evaluative dimension of content. Now, how do individuals become engaged in social cultural practices? Aren't we going to run into certain Wittgensteinian problems of how to go on correctly and then hit bedrock at one point?
Well, you mean Wittgensteinian problems? Because I don't think if you read Wittgenstein not Kripke's way, then he also says, well, there is no problem because in the end it's participating in a practice which solves the problem. It's a way of viewing at that practice and from a certain philosophical angle which he doesn't want to take, which brings you into those problems. It's precisely the point of view which Kripke takes. Yeah? So not necessarily,
but it's
because in that.
Do you have time for follow-ups? Very brief question in the back. You have a question? No? Yeah.
Actually, I wanted to point into the same direction. So because I think that you are about to shift burn pretty towards, as she just said, social cultural practices.
Yeah, sure.
So my question then is, okay, how do you account for the social cultural dimension in a fashion that is specific to REC? And I mean, you possibly are aware to like cognitive integration and enculturation accounts of what you call social cultural practices, and I'm wondering why you have to be a radical enactivist in order to defend such a position. And I would be interested.
You don't have to, well, I think any good account of that practice, wherever it comes from, is fine.
But why is
Perhaps.
that? I mean, but there must be a particular reason for you as a radical enactivist to endorse such a position, right?
No, what's specific about the REC position is that you say only then you have the conditions for content.
That's not specific to REC.
Okay, so you can carry this coffee break, and we will meet in 15 minutes for talk about science and